Hi everyone, welcome. This video is about my final C++ project, which is to create a simulation of John Conway's Game of Life. We're gonna use two-dimensional arrays, and each element of the array stands for a cell that is either alive or dead. And this project is gonna follow some rules regarding each cell's quote-unquote life. Each cell's life is gonna be affected by the number of its live neighbors, which are the adjacent and diagonal cells. And this program is then gonna follow some rules of the game. The first rule is a live cell with 2 or 3 live neighbors will remain alive. A live cell with fewer than 2 live neighbors will die due to loneliness, and a live cell with more than 3 live neighbors will die due to overcrowdedness. But a dead cell with exactly 3 live neighbors will become a live cell. And we also have a main menu showing a list of options the user can choose. R is to add additional 50 live cells in random locations in the grid, which means we'll need a srand function. G is to run for the next 10 generations. And to go to the next generation means to update the life of each cell based on the number of its live neighbors in the grid. And we are talking about simultaneous updates. Determine each cell's life based on the current pattern at one time. S is to run for the next generation. And basically, G and S are pretty similar because G is to put S function in a for loop and implement S function 10 times. C is straightforward, it's just to clear the grid. T is to ask the user to select a specific cell from the grid, and then if the cell is alive, kill it by marking it as dead. If the cell is already dead, make it alive. V is to save the current configuration in a file, and L is to load the configuration from a file. And let me show the output for example. We hit R and it's gonna generate some random pattern like this. And S is to create the next generation in the terminal. And as I mentioned before, simultaneous updates. It means each cell is being updated at one time. It's not like a cell is updated now and another cell is updated later. It all happens at one time. Okay, otherwise it's gonna mess up our grid. And if we select G, it's gonna run for the next 10 generations. If we choose C, it's gonna clear the grid and it's all blank now. So how I approach this project is first to develop the main menu. Like here, see out the main menu and create a switch statement to make sure the user's choice will lead to different output, and also do a do-while loop to make sure the program can be repeated again and again until the user wanna quit the program. My habit is to start from the big framework first, figure out what functions are needed for each case in the switch statement, and develop each function in detail. For explanation purposes, I'm gonna use IPO diagram, in which I means input, like what information we need from the user. And here, basically, the user just needs to provide their option. And if the user wants to toggle, the row and column numbers will also be needed. P of IPO means processing, like how we are going to process the user's option. And here comes the most important part of this project, which is functions. RC, T, V, L, and X, and this question mark, which is just to show the menu for the second time. All these functions are pretty easy and straightforward, but what is challenging is G and S, because they involve the creation and implementation of counting neighbors function, which means to put each cell in a 3x3 small grid in which the cell is in the center, surrounded by 8 neighbors. Go over each neighbor and count the number of the live neighbors to see whether the cell in the center will be alive or dead. So it's going to require you to create small two-dimensional arrays, and I call them sub-arrays from the 3x3 small grid, and use for loop to check each neighbor's life. Another challenge is to make the grid a round world. And what does that mean? That means for the cells at edge, like the cells on the top and cells at the bottom, the cells at the edge, they also have 8 neighbors. It's not like they're at edge and they don't have 8 neighbors. They still have 8 neighbors. Like this one, 8. It's not like there's nothing above it. Just because it's on the top of the grid, it still have 8 neighbors. So yeah, that is basically what I have for this project. And thank you so much for watching.